Okay, so for this question, it is a trigo graph concept mixed with your kinematic concept. Okay, so why is there a trigo graph concept? Okay, so let's read the information first. Okay, so there is a computer screen, 120 centimeter wide, and a dot oscillates in a straight line. That means it's actually moving. Okay, so how is the movement like? Okay, the movement is from O. So the movement is from O. From O, then you'll be moving along AB. So you'll be something like this. Okay. The dot will go to A, then it will move to B, then it will move back. So that is called one oscillation. Okay. So then you are given that it's X equal to A sine MT. So this is representing a displacement from O. So it will still be the same relationship. So if this is a displacement, I can get the velocity by differentiating. And I can get the acceleration by differentiating. So your trigo differentiation will be involved. Okay. And then if you see a function like this, it should also relate to you that this is the amplitude. So the amplitude is like the highest and the lowest. Okay. And then divide by 2. And this is actually the one that is responsible for the period. And in this question, they actually gave you the period. So the time for one oscillation is 6 seconds. So this is like a period. So from here, they ask you to explain why A is equal to 60. So A is the amplitude. So it's the maximum you can move, divide by 2. So like for example, a sine graph, the highest and the lowest divide by 2 will be the amplitude. So in this case, the maximum that the dot will go to is 120. AB is the maximum that the dots can be moving because it's just oscillating within that part. So the amplitude will be whatever the dot can move, divide by 2. So that's how we get A equal to 60. And in the case of period, you be aware that based on the expression, I can get the period formula. So this is the period formula. And because you are given that the period is 6 seconds, you equate the formula to 6, do your normal cross multiplication, you will get n equal to 1/3 half. So part A rely on your concept of amplitude and period of a trigo function. The next one relies on your concept of kinematics. For part B, we need to obtain an expression for the velocity. So displacement is represented by the sine function. So you need to differentiate the displacement formula. So when you do the differentiation, you are using the sine ax plus b equal to a cos ax plus b. So in this case, my a here is 1/3 pi. Okay, so I differentiate, I got the velocity. And we are supposed to deduce the maximum speed. Okay, so you look at the expression for velocity. It is totally restricted by the cosine function. Okay, why do I say that it's totally restricted by the cosine function? Because a cosine function can go as high as 1 and -1. So that is the maximum a cosine function can go to. So I will multiply by 20 pi. After I multiply by 20 pi, I will know that this is the maximum speed that this dot can achieve. So that's it. Now, later on, the last part, your job is to find the acceleration when it is at A. Okay, getting the acceleration is not difficult. Again, you need to differentiate. So from the velocity, you differentiate. So you will be using the differentiate cos AX plus B. Differentiate cos is minus sign, so you get minus A sine AX plus B. So you apply that. Okay, getting the acceleration is not difficult. So it is getting the timing at A. So what is the timing at A? So if you're not sure what's the timing at A, you will not be able to insert the T correctly and punch your calculator out. So that's why you need to know the original movement. So let me repeat the movement. So just now the question says that the dot starts from O, then it will go to A, then it comes back to O, then from O, it goes to B, then from B, it comes back to O. So that is a full oscillation. So if you look at the full oscillation, it has 4 parts. Okay, that's exactly why I wrote here. So the 4 parts took 6 seconds. So from O to A is just one out of the 4 parts. That's why at A, it will be 1.5 seconds. So there are 4 parts that the dots is moving. So it will be 1.5 seconds. You put in 1.5, you key in radian mode. So make sure your calculator is in radian mode. Okay, your calculator will return you a negative acceleration. The question is asking you for the magnitude. It's only the size of the acceleration. So we ignore the negative. So we just have to answer the question that the magnitude is this amount. It's the quantity. So we are not concerned whether it's a positive or negative. So that is the whole question on this application question.